These are notes for section 4.1. Okay, 4.1, page 204. We're solving a system of equations in this chapter. Notice every problem has two equations with two unknowns, x and y. They give you not one, but two equations. All the way through, there are two equations. Section 4.2, same thing. Section 4.3, same thing, except we're solving with different techniques. In section 4 will be word problems involving this. Okay, so chapter 4, it's going to be a lot of graphs. And on the next page, 7, 9, 11, 13, 15, 17, 18, 19, 20, 21, 22, 23, 25, and 27. Okay. So today we're doing the graphing technique, and we're trying to find points of intersection. Find an x comma y which satisfies both equations. The mode of operation is to graph the first line, graph the second line, and see where they touch. So maybe the two graphs would be something like this, and you graph one, you graph the other, and you just find out where they happen to touch. Okay, so number 1, x plus y equals 3, x minus y equals 1. Okay, so for many of the problems in this section, I've decided to just find the intercepts. Okay, where do they touch the x and y axes? So if I plug in x is 0, then y is 3. If I plug in y is 0, put a 0 there, that means x is 3. So 0, 3, 3, 0. And so if I plot 0, 3, and 3, 0, there's the first line. And then the second line, x minus y equals 1. So if I plug in x is 0, cover it up. Negative y equals 1 means y is negative 1. Plug in y equals 0, so x equals 1. So 0, negative 1, and 1, 0. Connect them, and they touch at the point 2, comma 1. Okay, so that's considered our solution, 2, 1. Double check, 2 plus 1 is 3, 2 minus 1 is 1. Number 5, x plus y equals 8, negative x plus y equals 0. Okay, again, I just plug in the zeros. When x is 0, cover that up, y equals 8. Likewise, when y is 0, cover that up, x equals 8. So 0, 8, and 8, 0, connect them. Second one, negative x plus y equals 2. Plug in x is 0, cover that up, y equals 2. Plug in y equals 0, put a 0 there, it's gone. Negative x equals 2 means x is equal to negative 2. 0, 2, negative 2, 0, connect them, and they seem to touch at roughly the point 3, 5. And if you plug in 3 and 5, you should check. 13, x plus 2y equals 0, 2x minus y equals 0. Okay, so if I plug in x is 0, you get 2y equals 0, y equals 0, so it touches the origin. So I can't pick 0 anymore. I decided to pick 1 for y. I plug in 1, x plus 2 equals 0, so x is equal to negative 2. So negative 2, 1, and 0, 0. Draw that line. Second one, plug in x is 0. You have negative y equals 0. That means y equals 0. So it goes through the origin. And then I decided to plug in 1 for x. Plug in 1, 2 minus y equals 0. Okay, that comes out to be y equals 2. So 1, 2. Connect them. And you can kind of tell we already saw that from over here. They touch at 0, 0 at the origin. 19, x plus 3y equals 3. Y equals x plus 5. This one already looks like y equals mx plus b. So I'll graph it in the format of y equals mx plus b. This one I'll pick the zeros. X is 0. Cover that up. 3y equals 3 means y is equal to 1. But y equals 0. 3 times 0 is 0. So x is equal to 3. So 0, 1, and 3, 0. Connect them. Looks like I have that. This one, y equals x plus 5, I'll use the y equals mx plus b format. So the b is 5. 1, 2, 3, 4, 5. Slope is 1. So over 1, up 1, and connect with that line. Okay, and I read where the touch seems to be about negative 3, 2. Okay, and when you plug in negative 3 and 2, you get a true statement. Negative 3 and 2, you get a true statement. So that's a way to double check. 27, x equals -4, y equals 6. X equals -4, you might recall, is a vertical line, undefined slope. So I go to x equals -4 and draw a vertical line. Y equals 6 is a horizontal line. Okay, so I go to y equals 1, 2, 3, 4, 5, 6, draw a horizontal line. And where do they touch? No big surprise, they touch at -4, 6, where x is -4 and y is 6. Okay, 25, something unusual happens. X plus y equals 4, 2x plus 2y equals -6. Okay, plug in x is 0, y is 4. Plug in y is 0, x is 4. So 0, 4, 4, 0. They're here, connect them. This one, when x is 0, 2y equals -6 means y is equal to -3. Likewise, if I plug in y is 0, you cover that up. 2x equals -6, x is -3. So 0, -3, -3, 0. Where do they touch? They don't touch, so there's no solution because the lines are parallel. There won't be any solution. Then the other extreme for our last example, 27, 4x minus 2y equals 8, 2x minus y equals 4. Okay, so plug in x is 0, 2y equals -8 means y is equal to -4. Plug in y is 0, 0 times that is 0, 4x equals 8, so x is equal to 2. 0, -4, 2, 0, connect them. Second one, plug in x is 0, -y equals 4 means y is equal to -4. Plug in y is 0, 2x equals 4, x equals 2. Well, we just graphed the same thing. So I use different colors. I'm not sure if you can see the different colors. One's in green, one's in red. But the lines are the same line. They coincide. So the answer is how many solutions are there? There are infinitely many solutions because the lines coincide. They happen to lie one on top of the other. Okay. So most of the time when you graph these, you'll have one point where they touch. Other possibilities, though, is that they don't touch because the lines are parallel. Or you could have infinitely many solutions because the lines happen to coincide. Okay, so this is section 4.1.